Greetings, mathematicians. Welcome to my narrated PowerPoint. It is a PowerPoint, but with the glorious addition of my voice. Now, in grade 10, you learned how to use the three trig ratios to work out the lengths of sides and angles in a right angled triangle. In grade 11, you learned the sine rule, the cosine rule, and the area rule. Now, in grade 12, we'll use all of our grade 10 and 11 concepts, but in 3 dimensions. But before we go any further, let's recap grade 11, because that was so long ago. First, the sine rule. The sine rule states that the sine of angle A divided by the length of the side opposite it will be equal to the sine of angle B divided by the length of the side opposite it, which will be equal to the sine of angle C divided by the length of the side opposite that. There we go. Now, in order for the sine rule to work, we need to have an angle and a side opposite that angle, as well as at least one other side or angle of that triangle. Let's do an example. There we go. You can pause the video at this point and try it yourself. Now that you've tried it, here's the answer. First, we say that the sine of angle x divided by the length of side opposite will be equal to the sine of 42 divided by the length of the side opposite that. Plug that all into our formula. Rearrange it using equation thinking. The 6 is dividing on the left, it will times on the right. Put that all in your calculator, and le voilà, as they say in France, you have an answer. But beware, when it comes to the sine rule, we have what is called the ambiguous case. If we are given two sides and one angle, and the side opposite the angle is the short side, that means there are two possible triangles that meet that description, and we could be asked to calculate two separate sets of answers. For example, if I have triangle PQR, there are its dimensions, and we're asked to determine the size of angle Q, there are two possible triangles that meet those descriptions. The first one looks like this. Or we could have a triangle that looks like that. Both of them have exactly the same dimensions as described in the question, but they are different triangles. So that means we will get two possible answers for Q. I said for Q. Don't be naughty. So angle Q will either be this. I'm using the sine rule as we used in example 1. There it is, giving us 75,64 degrees. That's angle Q. Or if I'm trying to find the other option for angle Q, I take my first answer for angle Q and subtract it from 180. And that gives me my second possible angle Q. So beware of the ambiguous case. Moving steadily along, the cosine rule. There it is. Does it bring back memories? I hope it does. The cosine rule works if we have got an angle and the side on either side of that angle and are trying to work out the third side. There we go. Or we can use the cosine rule if we know the lengths of all three sides and we want to work out the size of any of the angles. Let's give an example. Here we go. Try it yourself. Pause the video. Pause it. Don't be lazy. Do it. Now that you've tried it yourself, there's the answer. So we are looking for the length of this side, and we are given this angle C and the length of each side on either side of angle C. Put that all into our formula, I should say, and work it out. Beware that when you get to this point, this number is not the length of x because it is the length of x squared. So we still have to square root to get the actual length of side AB, which is 9,85 millimeters. Now, the area rule. The area rule, strangely enough, is a rule used to calculate the area of a triangle. There it is. Familiarize yourself with that. I hope it brings back memories. Here's an example. Yes, you can try it yourself. Now that you've tried it, here's the answer. This one's slightly different. We're not actually trying to work out the area. We are using the area in order to work out the size of an angle. But we take our basic formula and we put into it all the information we know. We know that the area is 174. We know the length of these two sides. What we don't know is the size of angle x, but that's fine. We put all of our information into our formula, and then it becomes an equation which we can solve like this. And we work out that angle x must have been 18,10. What? Did I just say 18,10? How appalling. 18,10 degrees. There we go. Any questions? Sorry, I can't answer that because I can't hear you. That, ladies and gentlemen, is a tractor. I don't know what it's doing there. Right. When to use each rule. If we are given the area, or we are required to calculate the area of a triangle, then we use the area rule. Who would have thought? If we are given all three sides and are required to determine an angle, then we use the cosine rule. If we are given two sides and the angle between them, and we are required to determine the length of the side opposite that angle, well, then we use the cosine rule. And if we're given an angle with the side opposite it, and then we are required to work out one of the other sides or angles, well, then we use the sine rule. And then we beware of the ambiguous case. Okay, dokie. Here are some mixed examples. Example number 1. Determine the length of BC. There it is there. In this diagram. Try it yourself. Pause the video. Try it. Now that you've tried it, here's my answer. First of all, I use the fact that angle A and this angle here are going to add up to 57 because of the exterior angles of a triangle. Remember that from grade 8? The exterior angle of a triangle is equal to the sum of the interior opposite angles. So we can work out that this angle here must be 18 degrees. Then we can use our sine rule. Now that we have this angle here, we can use our sine rule to work out the length of DC. So we use our sine rule, do some equationizing, and we work out that DC is 244,38. Presumably that's meters. I forgot my units. That's -1 points to me. Now that we have DC, you will notice in triangle BCD, that is a standard right-angled triangle, so we can use a standard trig ratio to work out the length of BC. If I've got this angle here, and I know the length of the hypotenuse, and I'm trying to work out BC, which is opposite to angle 57 degrees, that means I will have to use sine. Here we go. So sine of 57 is going to be equal to BC over the hypotenuse. There it is. Rearrange that and get our answer. BC is 204,96 meters. Forgot my units again. That's -2 for me. Right. Here's example number 2, which you can try yourself. Interestingly enough, this came out of a grade 11 exam paper, so it should be easy. Try it. Try it. Do it. Okay, let's answer A. We need to work out the length of BD. There it is. There's BD. Now we are given a side and an angle opposite it, which makes me think that we need to use the sine rule. So we use our sine rule like that, like this, and we discover that BD is 164,92 meters. Now to answer question B, we need to work out the length of side DC. Remember, we've already worked out how long BD is. So I've got this angle, and I've got side BC, and I've got side BD. So I've got an angle with the sides on either side of it. That makes me think I should use the cosine rule. There it is, the cosine rule. So I plug into it all of my values. And voila, there's my answer. No units yet again. That's -3. Gosh. Example number 3. Determine theta. Now, you might be panicking because it's all variables. There's no numbers. It's all y's. Why? 2y. Well, don't panic, because we can still use our cosine rule because we are given all three sides and we're being asked to work out an angle. So all three sides and asked to work out an angle, that means cosine rule. There it is. So I just plug into my cosine rule the values that I know. I know that AB is y. I know that BC is 2y. I know that AC is 2y. There we have it. Now, I need to be a little bit careful When I'm squaring 2y, I'm going to square the 2 and the y, not just the y. So 2y squared gives me 4y squared, or I should say 2y squared gives me 4y squared. And likewise, this 2y, when it gets squared, gives me 4y squared. Over here, negative 2 times 2 times 2 gives me negative 8, and the y times the y gives me y squared. You will notice I have got some like terms over here, so add those two together, I get this. Then I can take this 8y squared over to that side where it will subtract, and I get that. Now I can divide here. This negative 8y squared is timesing on the right, so it'll divide on the left. There we go. Then, vertical line. Negative 7y squared divided by negative 8y squared, you will find gives you this. Now that I have just numbers and no more variables, I can use my calculator. Second function cos 7/8. And huzzah! There's my answer.